Hello boys and girls, this is Mr. Kizik, and this video we're going to be looking at how to add and subtract radicals and multiply radicals. So this will be utilizing last week's lesson, which was just simplifying radicals. So in order to add and subtract radicals, you need to first simplify if possible, if necessary. You want to identify radicals with the same index and the same radicand. So in other words, what this means is that if you remember from last week, the same index means that there's the same number with that little radical symbol. Same radicand means this number inside the symbol has to be the same. If it's not the same, you cannot combine like terms. Just like when you have, say for example, 3x and 4x, you can add or subtract them, right? Because they're like variables. Whereas if I have 3x plus 4y, I can't combine those. And after that, for the common radicals, you're going to add and subtract the coefficients and then keep the radicals. So in other words, you're not doing anything on the inside. So for example here, number 1, 3 square root 27 minus 2 square root 12. Just by looking at this here, we cannot do anything with it. More than likely, we have to simplify something. So I got to simplify this square root 27. What's the biggest perfect square? 9. Square root 9, square root 3. And then the square root of 9 is 3. And then the square root of 3. Which then you can forget about this 3 that's also on the outside that you got to multiply with it. So this will be 9. I'll put this to the side. 9 root 3. If I do the other one, biggest perfect square is 4, and the other square is 3. We want to happen because we want the number inside the square roots to be the same. Because what happens then, to simplify 2 root 3, 2 comes on the outside, and now I have to multiply those 2, and I get 4 root 3. Now we can treat this problem like as if we were combining like terms. We have the same indexes, the same radicand, which therefore we just do the operation that's on the outside. So what's 9 minus 4? 5. So 5 root 3 would be my final answer. All right. Let's look at number 2. Number 2, all the indices are the same, so we have to simplify these cube roots. Now, cube root of 4, so we got to figure out what's the biggest perfect cube that can go evenly into 54, and that would be 27. And 2. The cube root of 27, that would be 3. Multiplied with this 3 on the outside, you get 9. Cube root of 2. This right here, the next one, that cannot be simplified any further. So I'm just going to rewrite that. 2 cube root of 2. Let's look at the next one here. So when I do this here, because the whole idea is I want to get the same radicand, there should be a cube root of 2 right here. And in fact, what is the biggest perfect cube that can go evenly into it? Be negative 8 in this case. So the cube root of negative 8 is negative 2, which when multiplied with the 7 gives me negative 14 now, because the cube root of negative 8 is 2 times 7, negative 14, cube root of 2. So now what you want to do is you want to just look at your problem and say, oh, okay. all the indices are the same and the radicands are the same. So therefore, just add or subtract the outside. So 9 minus 2 is 7. And 7 minus 14 is negative 7. So negative 7 cube root of 2 will be my final answer. And that takes care of the same thing for fourth root and such. So let's look at let's look at the next part, which is multiplying. This comes up more often than actually the adding or subtracting. So to multiply radicals, you need to use this product rule, where if the indices are the same, as you can see in this little thing here, n and n, then that means you can multiply the two things together. So if I look here, like number 7, 27, square root of 27 times the square root of 5. Those have the same indices. So therefore, that means I can just multiply the two things together. So if I do that, if I multiply 27 times 5, I get that this is equal to 135, square root of 135. Well, now I go about what I did before, which is to see if it needs to be simplified. So what is the biggest perfect square that goes evenly into 135? So if I do the math here, 36, 5, it looks like 9 is the biggest perfect square that goes evenly into it. And then I have 15. Well, what's the square root of 9? 3. And then the square root of 15 comes along for the ride. Let's look at number 8. Number 8, I have 3 square root 10 times negative 2 square root 18. Well, the indices are the same, so therefore I can just go about multiplying them. So I can multiply the insides, 10 times 18, which is 180. And I can also multiply the outside, 3 times negative 2, which is negative 6. Now I just go about simplifying just like I did before. What is the biggest perfect square that goes evenly into 180? So when I do the math here, oops, it looks like 36 and 5. What's the square root of 36? It's 6. So this goes down to 6 square root of 5, but don't forget I gotta multiply this negative 6 afterwards on the outside. So my final answer is negative 36 square root of 5. If I look at number 9, for example, actually let's utilize the variable to number 11. If I looked at number 11 here, I have the same indices, so that tells me that I can multiply the two things. So if I multiply the numbers on the side, 1 times 5 is 5. Multiply what's on the inside symbol. So 6x to the 4th times 8x to the 5th would be 48x to the 9th, because you might add the exponents when you're multiplying variables. And now you gotta go simplifying. What's the biggest perfect square that goes evenly into 48? 16. And the other factor is 3. Square root of 16 is 4. Square root of 3. And don't forget the 5 needs to multiply out to 4. So I get 20 root 3. And now, if you remember from last lesson, I have to utilize the variable. So now I take the exponent, 9, divide by the indice, 2. 9 divided by 2 is 4 with remainder of 1. So my variable portion would be x to the 4th on the outside and just x on the inside. And that will final answer. The last thing we're going to look at is looking at what they call binomial examples. In other words, when you're just multiplying a square root or a radical or something across the parentheses. So I'm going to give you the hardest example here, which is probably like number 16 here. This should look familiar because it's like foiling. It's like if I had something like 8 minus x times 3 minus x. You just FOIL. So let's do that here. 8 times 3, 24. 8 times negative square root 10. Well, the 8 and the 10 cannot combine because one's outside, one's inside. So that just becomes minus 8 square root 10. Negative square root times 3 is the same concept, so minus 3 square root 10. And then what's negative square root 10 times negative square root 10? Well, what's happening here is I get what? Plus square root of 100. Because of the same indices, I can multiply by the inside. Now let's go about simplifying. Well, first thing we should have noticed was square root of 100 gives me what? 10. So I can combine 4 and 10 to give me 34. And the other thing we notice is that we combine these two here because the square root 10s are the same here. So negative 8 minus 3, which is a negative 11 square root 10. And that, ladies and gentlemen, is how you add, subtract, and multiply radicals here. So what I would like you to do for homework are problems 1, 5, 7, and so for homework, I want you to do